Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Here we are going to see the projections of plane surfaces when inclined to one plane, right? Hope you are enjoying these lectures on engineering drawing. Do like, share and subscribe. Now, let's see the projections of planes. A triangular lamina of 50 mm edges resting on one of its edges in HP. Okay. Its surface is making an angle 45 degrees with the HP. So earlier we have seen only the plane surfaces when they are like this. When it is in HP or parallel to HP or in VP or parallel to VP. But now here it is making an angle with the horizontal plane. So here it's resting on one of its edges. If you observe this triangle, I have taken this triangle has one edge here perpendicular to VP and on the other side we have a corner. Now suppose if we are this, that means here we have an edge, this side we have a corner. Because its surface is making an angle with the HP, we lift the planes like this. In the front view, if you lift this side or this side, you'll be getting the surface angle with the horizontal plane. Now, suppose if I lift this here in this side, what happens? I have a edge. This is the edge here, right? This side. When you lift this up, we get a edge in the horizontal plane and the surface will be making an angle. How do you say that surface is making an angle means here the line, it appears like a line in the front view. When this line is making an angle with the horizontal plane, that itself is an indication that its surface is making an angle with the HP. Now, this is the actual position. When you lift this up, the front view will be same. There is no change at all. Just the same size of length, same length will be there, and but at an angle. At some angle, given angle, you will be lifting it up. So this side we have a corner, and this side here we have an edge. How do you say? In the top view, we can see that. That means here this edge is in the horizontal plane, and the surface is making an angle 45 with HP. So like this, we have to assess and before you draw it, plan the problem accordingly. Now, let's draw the projections. So first of all, you take an edge, you draw the triangle in which view, first of all. So here, the surface has one of its edges in HP, that is one indication. So you take the plane in the horizontal plane. How? One edge perpendicular to the reference line like this. You take the edge, this edge, say AC. AC is perpendicular to VP. Now, draw show the dimensioning and draw the front view. Already we have seen. So, this is the front view. After getting the front view, we have to lift. Which side? I will lift this point B. That means this plane, entire plane is lifted upwards like this, keeping this point AC in the horizontal reference line. So when you lift it up, this surface makes an angle. How much? 45. So we draw a line here at 45 degrees angle, okay, and mark the same length here, right? We mark the same length, whatever it is, the same length is marked here, and there is absolutely there is no change in the front view, the points and everything, but only at an angle, that's all. Now, when you are lifting it up, the points in the front top view are at the same distance. We are not moving the plane from the vertical plane. So all these points are at the same distance in front of VP. So the point B, A, C, everything will be at the same distance. But here, when you are lifting it up, the top view of point B as well as other points will be on the same projector, right? On the same projectors here, drawn through the points. So let's draw projectors from all the points A, B, C, D, A, B, C. Now, when you are lifting this in the top front view, we are able to see that this line is lifted and is making an angle. That is, this surface is making this 45 degrees angle with the HP. In the top view, the points are at the same distance in front of VP. Already we have discussed. Now that means let us draw horizontal lines from these points. What happens? The point A is at the same distance in front of VP. Point B at this distance. C at this distance. Okay. Now A and A dash will lie on the same projector. So from A dash we have drawn a projector, and this point from A you have drawn a horizontal line. This intersection point is called A. Similarly, from B a horizontal line, B dash a projector. This is B in the top view. Similarly, C. After getting these points, join them by straight lines. AB, BC, CA. Close it. So the top view appears like this. Okay. Now, so these are the final projections of the plane when its surface is making angle with one plane. Now, let's take another case. Triangular lamina of this much size resting on one of its corners. Earlier we have seen the edge. Now it is lying in corner. Its surface is making an angle 45 with the HP. If you observe the plane, it is like this. Now, this side we have a corner, right? For this plane, we have a corner on the right side. That's why we have lifted on the left side. When you lift this up, this here we have edge, and here this point is corner. So the corner is in the horizontal plane. Okay. So the surface is making an angle 45 degrees with the horizontal plane. Now the top view appears like this. Let us draw the projections. Draw the reference line. First we have to draw the top view, a triangle in the top view. And how? The edge, we take one edge perpendicular to the reference line, perpendicular to the VP, Y, because we want the edge in the horizontal plane. Okay, we want the edge in the horizontal plane, or okay, that is in the previous case. Now we want the corner. If you want the edge, you take the edge perpendicular to VP. If you want corner, you take the corner such that it comes on one side, either left hand side or right side. Here the point B has come in the right side. So our condition will be satisfied. We'll see how. Show the dimensions, draw its front view, projectors and front view. Already we are well versed with this. Otherwise, you please refer the previous videos. Now, let us lift this A dash C dash upwards. AC is lifted upwards. And we draw a line here at 45 degrees angle. 45 degrees with the HP. So 45 degrees line here drawn. Mark the same distance, same length here on this. Right? Point B must be taken on the reference line because we want the corner. B is only a corner. So the corner is in the horizontal plane. So take the corner B in HB, and this is A dash C dash. Now, as already we have seen, draw horizontal lines from these points and draw projectors from these points that get the corresponding intersection points like this. Draw horizontal lines. Now, corresponding intersection means A dash and A here. The intersection point is A. Here B, B dash, B. Likewise, whatever may be the number of points, get these intersection points here like this. Join them by a straight line. Each one is joined by straight lines. That gives you the final projection in the top view when the surface is making this 45 degrees angle with the HP. You see the difference between the earlier one and this one. Earlier it was the edge which is lying in HP. Now it is the corner which is lying in the horizontal plane. Okay. Now let's take a square lamina. Size is given. Resting on one of its edges. When you want an edge in the horizontal plane, it's an indication that the plane will be in the horizontal plane. First point. Second, when you want the edge in the horizontal plane, you start the square or any polygon such that one edge, one line is perpendicular to the vertical plane. Okay, now let's draw this. Okay, so here let's see how the plane is. So this is the square lamina on the in the horizontal plane here, and this side, left side, we have an edge, and this edge is in the horizontal plane. Okay, and the surface is making 40 degrees angle with the HP. So the projections will be like this. The plane position is like this. Let's draw the projections now. Take the one edge perpendicular to VP because we want one edge in the horizontal plane. So the entire plane is taken in the horizontal plane itself. Okay, name these points, show the dimensioning, draw its front view. It's simple, already we are well versed with this. So the front view is drawn. Now, which side you have to tilt? Either shall I left the right side like this or left side? You can in any direction, either left side or right side. It will result in one side, left side we have an edge AD, right side we have an edge BC. So if you are lifting this side, BC will be in the horizontal plane. If you are lifting this side, AD will be in the horizontal plane. So for this case, you can lift on any side. Okay, we want 40 degrees angle with HP. Draw a line at 40 degrees. Okay, and mark the same length here, A dash, B dash, whatever the length here it is. Mark the same length here, and that is the front view. When the surface is making 40 degrees angle with the HP. Mark the same points here. Absolutely, there is no difference. Just we are moving. That's all. Now, the same points in the front view are marked. Now, you know, in the horizontal top view, draw horizontal lines. From the front view, draw vertical lines. You know why. So, draw projectors and horizontal lines here like this. Get the intersection points. So, these intersection points from here and here, this is A, this is B, C, D. Join them by a straight lines, and here these are A, B, C, D. So this is the final projection of the plane when its surface is making angle with the HP. Now, let's take another one. Square lamina of 50 mm edges resting on one of its corners. So we want the corner on one side, corner on HP. Because the corner is in HP, it's an indication that almost the plane is in HP. First point. Second, its surface is making angle with the HP. When the surface is making angle with HP, initially you take the plane in the horizontal plane or parallel to the horizontal plane. Okay, so these two indications must be clearly observed. Next, the plane is actually like this. We want the corner in HP. That's why you try to get corner on either left side or right side. But here, because it's an even number of corners are there, if you take the corner on left side, automatically you are getting the corner on the right side. So when you lift this upwards, this corner here is in the horizontal plane, and the surface is making an angle with the HP. So the final projection in the further plane will be like this. Let's draw the projections. Draw the horizontal reference line. First, you try to draw the square such that you get the corner on left side or right side. Here, of course, we are getting on both sides. No problem. Now, show the dimensioning. Mark the project points. Draw its front view, right? A dash, B dash, C dash, D dash. The front view is drawn. That's over. Now, we want this at 40 degrees angle. The front view, this line will be at 40 degrees. How? You either lift C upwards, you get corner A in HP. You lift A dash upwards, C will be in HP. So either side you can do that. So here I want to take A in the horizontal plane. So lifting C upwards, draw a line at 40 degrees, mark A dash, C dash, same length here. The same length is marked. Now, mark these points and draw horizontal lines from here, and vertical lines are the projectors from these points. Get the intersection points. A. So this is A dash, A dash. Here it is A. So this point will be A. Similarly, here B, B dash. This is B. Because these are the top view points, we mark them as A, B, C, D. So after getting these intersection points, join them by straight lines like this. This is the final top view. This is the front view. Okay. So here the plane surfaces are making angle with one of the reference planes. Okay. Hope you had understood this topic very well. If you have any queries, please do send through comments. Do like, share, and subscribe. Thank you.